In this video, we want to talk about some examples that can use the algebraic properties, meaning the associative property, the commutative property, and the distributive property. We want to look at some expressions similar to the two we have here and a couple more that will illustrate to us how the properties can be used in these types of settings. Now, if I wanted to do this in my head, I could. I could add 3 plus 6, then subtract 2 from that, and then subtract 3 from that, and it wouldn't be too difficult. As long as I'm working from left to right, then I would get the correct answer. However, it can be easy to lose track of signs or numbers or anything like that in your head, so sometimes there are easier ways to do these using the properties. For instance, in this one I notice I have a 3 and I also have a negative 3. If I can get them together, I can take 3 plus negative 3 and that'll give me 0. So essentially they'll be gone from the expression. So using the properties, I'd like to move that negative 3 over so it's close to the positive 3. However, I have subtraction in here. Remember that addition and multiplication are both commutative and associative, while division and subtraction are not. So what we're going to do is we're going to use our little handy trick here, and rather than writing minus 2, I'm going to take plus negative 2 and plus negative 3. So I've changed my subtraction to adding the additive inverse. And I'm able to now do whatever I want using the associative and commutative properties. So I can, for instance, switch my negative 3 and my negative 2, right? So I have 3 plus 6 plus negative 3 plus negative 2. So I've switched these two numbers here. And I can do that because of the commutative property. Addition is commutative. So I know that this is okay. So that's the commutative property. Now I still don't have 3 and negative 3 together, so I think I want to do that one more time. I want to switch that plus 6 and that plus negative 3. So I'm going to switch these two. So I have 3 plus negative 3 plus 6 plus negative 2. So now I've used the commutative property again, and I have 3 and negative 3 together. Now the associative property tells me that I can start adding anywhere I like. I can take any two together and add them, and that's fine according to the associative property. So I'm going to start at the beginning. I'm going to start with the 3 plus negative 3. The reason I wanted those together was I knew that they were going to cancel each other out, so I get 0. I'm adding 3 and its additive inverse. So then I have my plus 6 and my plus negative 2. Again, using the associative property, I know that I can choose any two numbers to start my adding as long as they're together. So the 6 and the negative 2 is going to give me 4. So now I have 0 plus 4. Well, that's just 4. So that's our final answer. So notice this is a lot of writing. This is a lot of steps. As we get more comfortable with this, we won't have to write out every single step every single time. We'll get a little bit more fluent in going between these things. But it's good to know exactly what properties we're using to get there, so that if we ever needed to, we could justify why we did what we did. Now let's look at the second example. This one's a little longer. We have 1 minus 1 plus 2 minus 3 minus 2 plus 4. So I already noticed I have a 1 and a negative 1. I also have a 2 and a negative 2. So if I can use some sort of associative property and commutative property, I can get those two sets together, and those are both going to cancel out to be 0. So in order to use the properties, I need to switch the subtraction, right? So I want to add the additive inverses. So before I even do anything else, the associative property tells me I can take any two and start there. So I'm going to take the 1 plus negative 1, right? Because that's going to give me 0. So I'm just going to get those out of the way. That's one less thing I have to keep track of as I keep going. So I have plus 2 plus negative 3 plus negative 2 plus 4. Now the other thing we noticed was that if we could get our 2 and our negative 2 together, then those would also cancel and we get a second 0. So I'm going to use the commutative property to switch my plus negative 2 and my plus negative 3. So I've just used the commutative property to switch those two. Now the associative property again tells me I can start with any two that are next to each other and add those. So I'm going to do the same thing I did up here with the 1 and negative 1 and add the 2 and negative 2. So I get 0 plus negative 3 plus 4. Well, the zeros aren't going to change anything. All I'm left with are the negative 3 and the plus 4. So negative 3 plus 4 is going to give me 1. And that'll be my final answer. But I want to change up this example for just a second. We're actually going to look at this slightly different. 1. So we have negative 1 plus 2 minus 3 minus 2 plus 4. I've just gotten rid of that very first 1. And I want to see how that changes our strategy. So notice I only have one pair of a number and its additive inverse now. I want to get those together. But I also am noticing I have a negative 1 and a negative 3 once I change these to additive inverses. And I know that if I add negative 1 and negative 3, so if I can get them together, I'm going to get negative 4. So if I actually use the commutative property to switch the 2 and the negative 3, I end up with negative 1 plus negative 3 plus 2 plus negative 2, and then that plus 4. So I use the commutative property to switch these two. Now, before I even look at the negative 1 and the negative 3, I see that I have 2 and negative 2 together. So first of all, I want to combine those because that's easy. I know that that comes out to 0. Now notice if I take negative 1 plus negative 3, I'm going to get negative 4. The 0 isn't actually going to change anything, so I can drop that. So I end up with negative 4 plus 4. So by grouping the negative 1 and the negative 3 together and adding them, I was able to get an additive inverse for the 4, even though it wasn't immediately obvious to me in the beginning that I had that. So now I can add these, I'm going to get 0. So this whole equation would come out to 0. So sometimes it's obvious that we have a number and its additive inverse. Sometimes it's a little bit more hidden, like the negative 1 and the negative 3. So that's always a good thing to look for too, to see if you can find some combination that'll give you an additive inverse for something we already have. So we haven't actually talked about the distributive property yet, because the distributive property is tied pretty closely to multiplication. So let's do a couple more examples, and let's put some multiplication and division in there, so we can practice the distributive property. So, let's think about this. Let's take 4 divided by 5 minus 3 minus 2 plus 2 divided by 5. So how I have this right now, it doesn't actually even look like the distributive property is involved, does it? Because I have division, I have subtraction, I don't see any multiplication over a set of addition. This looks like the closest thing that's going to get me there, but right now I have it as division. But remember, division along with subtraction are not associative and not commutative. So if I can change them to multiplication and addition, I want to. So remember that dividing by 5 is the same thing as multiplying by the reciprocal of 5. So what I really have here, if I want to rewrite it, is 4 times 1/5 plus negative 3 plus negative 1 times 2 plus 2 times 1 over 5. Notice here that I changed this minus 2 plus 2 into plus negative 1 times 2 plus 2. Because I have this expression in parentheses here, I want to be able to remember that I have a negative out there, and just it makes it a little easier to put the -1 here instead of just a negative sign. It helps us to remember it has to be distributed through. And we can always assume there's a 1 out in front of parentheses. So I understand there's a 1 there, so it's minus 1 times 2 plus 2, or plus -1 times 2 plus 2. Now I have two different ways I can do distribution, right? I can use the distributive property with the 1/5 and also with the -1. So let's use the the 1/5 first. So I have 4 times 1/5 plus -3 plus -1, and 2 times 1/5 is just going to be 2/5. Now I see another place where I can use the distributive property. Right there. The -1 needs to be distributed through. So I still have the same thing everywhere else. But now instead of the plus -1 times that, I have plus -2/5 plus -2/5. I just multiplied each of these terms by -1. Now, notice I have fractions that are over 5 here, and I'm going to have one here also. So I think that what I want to do is I want to actually combine these together rather than trying to manipulate first, because then I'll have one piece over here that has a fraction over 5, one piece over here. Then I'll have some like terms, I can do some combining. So 4 times 1/5 is the same as 4/5 plus -3 plus, and then the -2/5 plus -2/5, I have common denominator, so I can just add right across the top. So I have -2 plus -2, that's going to give me -4, and then over the common denominator, which was 5. So see now how I ended up with 4/5 and the additive inverse of 4/5. So if I can get them together, I can add and get 0. Well, that's just one easy application of the commutative property. So I end up with 4/5 plus -4/5 plus -3, which is going to be 0 plus -3. Well, 0 plus a number is always the number itself. So we get -3 as our answer. Now, notice there was a second way I could have done this problem. And when we're dealing with expressions like this that only involve numbers, we're kind of always going to have this choice. I had this 2 plus 2 in the parentheses, and I chose to use the distributive property. I actually used it twice. And this is the most important application that we had here, because this distributive property is pretty standard, but remembering this -1 needs to be distributed through is really important. However, I could have started a different way. What I could have done is I could have said, okay, I have 4 times 1/5 minus 3 minus, and then rather than 2 plus 2, I could have done that in my head and gotten 4. I could have just added them together. And then divided by 5. So notice that this time I'm not actually going to use the distributive property. So I've already changed some of my division, but let's finish. So I can multiply by 1/5 and change my subtraction to adding the inverse. So what I end up with is 4/5 plus -3 plus -4/5. So I end up exactly where I was down here. Again, I can use the commutative property to get the 4/5 and the -4/5 together. I get 0 plus -3. And I get -3. So either way that I want to do this is fine. We have a lot of options because we're only dealing with numbers here. We don't have any variables, we don't have anything else we have to worry about. So we have lots of options. Now let's just try one more example. Make sure that we're clear on these. So let's take 2 times 1 divided by 3 plus 3. Then we have minus 1 minus 2 divided by 3. Now by order of operations, I would know that I have to divide 2 divided by 3 before I deal with that negative, but I put parentheses in just so it's clear. So again, it looks like I'm going to have some sort of distribution here, but I still have division, I still have subtraction. So it's not clear how the associative property and the commutative property are going to play out. And even the distributive property is a little bit strange with the 1 divided by 3 there. So let's change division to multiplying by the reciprocal, and let's change subtraction to adding the negative inverse. So again, I can always write division in this form and think of multiplication then involved. So, it looks like this is a good place for distribution, right? I have 2 being multiplied into, in parentheses, 1/3 plus 3. So I'm going to get 2/3 plus 3 times 2, or 6, when I distribute there. Then I still have plus negative 1, and then plus negative 1 times 2/3, or negative 2/3. So again, I could have done the same thing I did in the last problem. I could have tried to combine the 3 and the 1/3 first. However, I noticed that I had fractions that had 3 in the bottom elsewhere, and I noticed that the 3 and the 1/3 didn't have a common denominator. I'd have to find a common denominator, in order to add them. So I decided that I was going to just straight up distribute first. And it looks like that was a good choice because now I have 2/3 here and negative 2/3 here. So if I can get those together, then I can make that 0. Well, if I switch out my negative 2/3 and my negative 1, and then I switch that with the 6, I'll end up with the 2/3 and the negative 2/3 together. So I'm just using the commutative property twice. And I'm just going to write it as one step so we get used to it. So now I know that these first 2 terms add up to 0, plus 6, plus negative 1. So that's going to give me 0 plus, and then the 6 plus negative 1 is going to give me 5. So that would be my final answer there. So sometimes it's just as easy to add inside the parentheses first. Sometimes it makes a lot more sense to distribute. It really doesn't matter either way. It's just sometimes one makes more sense than the other.